Hey everybody, it's me again. So, have you ever had Dippin' Dots? The ice cream that's out of this world? All those tiny little delicious dots. How many dots do you think are in a cup? There's way too many to count. That's what early chemists thought about looking at a sample of matter. Atoms are way too small to see, but chemists are all about keeping track of matter. So they invented their own unit of measurement that represented this huge number. It's called a mole. A what? No, not that kind of mole. Ooh, okay, that's not what I'm talking about. When chemists talk about a mole, they aren't talking about condiments either. They're talking about Avogadro's number, a unit of measurement. 6.02 times 10 to the 23rd power. This fantastically large number called the mole is used to represent this many of anything. Don't get scared, it's just a number. And you've been able to count probably since you were 2 or 3 years old. You can have this many dollars, this many footballs, this many pizzas, this many, well, anything. Using units to count is nothing new. When you have a pair of socks, you have 2. When several friends are going to a party, that usually means 3 or 4. When you have a dozen of something, then you have 12, right? And in chemistry, when we say 6.02 times 10 to the 23rd power, we're usually talking about something like ions, atoms, molecules, and formula units. Remember, chemistry is all about studying matter. That's all chemists really care about. So this means that a mole of matter takes up space. Has a mass and a volume. Let's look at this mole business a little closer. Hey, we'll even use my favorite element, carbon, as an example. 1 mole of carbon has 6.02 times 10 to the 23rd atoms. 1 mole of carbon, if it were to exist in the gas form, would occupy 22.4 liters. Where did that number come from? You'll learn about gas laws a little later, so just go with it for now. Also, 1 mole of carbon contains 12.01 grams of carbon. Well, where did that number come from? Yep, you guessed it, your periodic table. 1 mole of any substance is equal to its atomic weight, and carbon is like the standard. All other elements' weights are relative to carbon. So, if 1 mole of carbon has a mass of 12.01 grams, how many grams are present in 1 mole of iron? Well, don't look at me. Look at your periodic table. 1 mole of iron contains 55.8 grams. See the atomic weight? It's right under the element symbol. Now, I'm pretty sure you can find the mass of 1 mole of any atom. Just use your handy-dandy periodic table. What if I have 2 moles of iron? How many grams are present? Well, you can multiply, right? There are twice as many grams, or 111.6 grams. So, what if I have half a mole of iron? How many grams is that? I believe you can divide too. There are half as many grams, or 27.9. Now, I want to make sure your head doesn't explode, so I'll save any additional math problems for another video. Trust me, this crazy number called the mole isn't going anywhere anytime soon. You'll actually use it this entire year in your chemistry class. So I want you to get this. But I promise, you'll get this and you'll do great. Let's think back to those delicious Dippin' Dots. Trust me, ice cream is way easier to think about. Wouldn't it be cool to work there? What if you were the manager? How could you make sure that each pint of Dippin' Dots you sold contained the same number of dots? You want to be fair, right? No one should get too many or too few delicious dots. It would be impossible and utterly ridiculous to try and count the number of dots that went into each container. But what if you knew the average mass of just 1 dot? Aha, okay. You don't need to count out every dot. You can just fill the pints up by weight. Let's pretend you want every pint to contain 1,000 dots. If one dot weighs 1 gram, then 1,000 dots weighs 1 kilogram. Problem solved. There's no need to count out every single little dot. All you need is a scale. This is how chemists keep track of atoms, by measuring weight and using the mole. Well, that just about wraps it up for me this time, but come back next time and I promise there'll be more cool stuff on the mole. Thanks, guys.